Hi, this is Mrs. Baisden, and today we're going to do some heating curve practice problems. So this is some information you would need before you start your heating curve calculation. So you would need to be able to calculate or convert between joules and kilojoules. You would need to know the heat of fusion, which is 6.02 kilojoules per mole. And you would also need to know the heat of vaporization, which is 40.7 kilojoules per mole, and these values are for water. You would also need to know the specific heats of solid, liquid, and gaseous water if you're doing the calculation for water, and those are given below, and those would be given on any quiz or test that you would be expected to take. So this is the first one, and this goes right along with the practice sheet that you're working on in class. So the first question says, how much energy in kilojoules is required to change 25 grams of ice at minus 10 degrees to steam at 150 degrees Celsius? So when you start these problems, you have to figure out how far you need to go on the graph. So is this one that's going all the way from ice past steam, or is it something in between? So for this particular one, if I'm starting at minus 10, that means I'm starting as a solid. So we're going to make this first point on the graph here minus 10. Then the next point that I care about on the graph is the freezing point, and that's going to be 0 degrees Celsius. And again, this is just for water. The next point is going to be 100 degrees Celsius. That's where the boiling point is. And then the final point, we're going to make the final temperature, which is 150 degrees Celsius. So for this particular one, you're going to use all 5 parts of the graph. So we're going to do 5 different calculations and then add them all up. Okay, so for the first calculation, so for this part right here, number 1, this is a temperature change. So to calculate the energy involved with this temperature change, we're going to use Q equals mc delta T. So the mass is going to be the mass that they give us in the problem. So the mass is always going to be 25. The C for this one is for solid water. So if we look up our specific heat for solid water, it's 2.06 joules per gram degree Celsius. And then the other piece of information we need is the temperature change. So to get from our minus 10 to 0, that's a 10 degree temperature change. So our delta T is going to be 10. So then we would do that calculation. That would give us 515 joules, which is 0.515 kilojoules. So that's for our first step. Our second step on our graph, so step 2, is a phase change. So at this point here, it is going from a solid to a liquid. So we're going to do a conversion to figure out how much energy is associated with that. So we're going to start with our mass of water that we're using here. We're going to convert that to moles using the molar mass of water. Then we're going to use our heat of fusion. So it's 6.02 kilojoules per 1 mole. So for the phase change, there's 8.35 kilojoules of energy involved. So that's our second part. For the third part, we're back to a temperature change. So we're back to Q equals mc delta T. So our mass is 25. This time, since this is liquid water, we're using the 4.18. And then our temperature change is between 0 and 100. So our temperature change here is 100. So for this one, it's 10,450 joules, which is 10.5 kilojoules. So what I'm doing is I'm converting all of these to kilojoules. So when I'm ready to get my total, I can just add them all up. All right, so now we're at step 4. So step 4 is another phase change. This time we're going from liquid to gas. I still have 25 grams. I'm still going to start by converting that to moles using the molar mass of water. And then this time I'm going to use the heat of vaporization. So the heat of vaporization is 40.7 kilojoules per 1 mole. So for this particular one, or this particular segment, I have 56.5 kilojoules of energy needed to change that from a liquid to a gas. And then finally, the last part is this segment right here. So I have a temperature change. So I'm back to Q equals mc delta T. Mass is still 25. This time, this is a gas, so I'm using the specific heat for a gas, which is 1.87. And those constants would be available to you just like they were on the previous slide. And then my temperature change for this one is from 100 to 150. So temperature change there is going to be 50. So for this one, I would end up with 2,338 joules, which ends up being 2.34 kilojoules. So those are my 5 segments of the graph. So then the last thing I need to do is I need to go back and I'm going to add all 5 of those up to get my total. So when I add all of those up, my overall Q, or overall delta H, however you want to report it, ends up being 78.2 kilojoules. So that's my overall energy change associated with this particular 25 grams of ice going from minus 10 degrees Celsius to 150 degrees. Okay, this slide here just shows a little more detail if you want to just kind of review this one more time if it's still a little bit confusing about what to do here. This slide just breaks it down in a little more detail about what's going on at each step. So if you know what you're doing, go ahead and skip through this. So when we're looking at what this is, our substance is water. So what that tells us is what our melting points and boiling points are. So for water, we know our melting point is going to be 0, our boiling point is going to be 100. We have to know the amount involved because this is something that depends on how much of a substance you have. The starting point and the ending point are also important because that tells us what pieces of the graph we need to include. So we started out down here at minus 10, we ended up here at 150. So for the first part of the graph, this was a temperature change. So we used Q equals mc delta T, and then we went from minus 10 degrees Celsius to 0 degrees Celsius, and we had to use a specific heat for ice. Part 2 was a phase change. So this was a conversion using that delta heat of fusion, and this was for a solid to a liquid. Step 3 was a temperature change from 0 to 100, so we used Q equals mc delta T. This time the C was for water, which was 4.18. For the 4th segment, this was another phase change, liquid to vapor, so we used the heat of vaporization. And then finally our last step was another temperature change from 100 to 150, so we were back to Q equals mc delta T. This time we used the specific heat of steam. Once we had all those, then we added them all up, and that's how we came up with our total. Okay, so then number 2 on your graph is a little bit, or on your sheet is a little bit different. So number 2, now we want to know how much energy is required to melt 50 grams of ice, so we have a little different amount this time. It starts out at minus 18, and it goes to liquid water at 25. So if you look on your paper, this says liquid water, not steam. So if I look at my graph, that's going to tell me how much of the graph I need to do and how many calculations I need to do. So if I'm starting out at minus 18, I know this is going to be ice. So this is going to be before it becomes liquid water. So that's going to be this first segment from negative 18 to 0. So that's going to be my first step. Then it's going to go through the phase change. So I'm going to need step 2. And then the third part of this only goes to 25. So this time it's not going to go all the way to the next phase change. We're only going from 0 to 25. So for this particular one, I only need 3 parts of the graph. So I'm only going to have 3 calculations to add together. So for this one, for step 1, it's a temperature change. So Q equals mc delta T. The mass this time is 50. C for ice is 2.06, and my phase change, because my temperature change, because I'm going from minus 18 to 0, is going to be 18. So for this one, I have 1,854 joules, which is 1.85 kilojoules. Step 2 is right here. This is a phase change. So I'm using my conversion, so 50 grams, change it to moles, using molar mass of water. And because it's melting, I'm using the heat of fusion which is 6.02 kilojoules per 1 mole. So that gives me 16.7 kilojoules. And then my third step is another Q equals MC delta T. Mass is still 50. I have liquid water, so this time I'm using 4.18. And delta T is only from 0 to 25. So my delta T is 25 because that's where the problem tells me to stop. So Q for this is 5,225 joules, which is 5.23 kilojoules. So then, at that point, I'm going to add those 3 steps together. So that gives me an overall Q, or delta H, of 23.8 kilojoules. So 23.8 would be the total for that one. So here's a little more detail about that one. We're using water again, but this time we have 50 grams. The starting point was -18, the ending point was 25. So that's why we only needed 3 pieces, because it didn't go all the way to the phase change, it didn't go all the way to steam. So this one, we only had the 3 steps, and then we were adding those 3 together. Number 3. So number 3 says, how much energy is required to change 25 grams of ice at 0 degrees from a solid to a liquid? So for this particular one, if we look at our diagram, this is just a phase change. There's no temperature change. They're just saying this is 25 grams at 0 degrees. So this is only one piece of the graph. So for this one, we only need one calculation. We just have to do a conversion. So 25 grams of water, change it to moles. And then because we are melting it, we're using the heat of fusion, which is 6.02 kilojoules per 1 mole. So this ends up being 8.35 kilojoules. So this one, because we're not changing temperature and we're only changing one state, there's only one step to this particular problem. That's why it's important to think about where you're starting and where you're ending up, because some of these problems only need one step, some can need as many as 5. Then the last problem that I have on here that'll be worked out for you is number 4. So number 4 says how much energy in kilojoules is required to change 12 grams of water from 5 degrees Celsius to 95 degrees Celsius. Okay, so again, we're going to start by thinking about where is this on the graph. So for this one, we're starting at 5 degrees. So we know this phase change happens at 0. So that means for this one, we're actually starting a little bit above that. Then we're going to 95. So we know this flat line here is 100. So we are ending a little bit before there. So for this one, we only need this piece of the graph. So again, only one step here, and for this one, we're just talking about a temperature change. So this problem only needs Q equals MC delta T. So mass for this is 12 grams. Since this is in the water section of the graph, this is when you have liquid water, we're using 4.18 as our specific heat. And then our temperature change for this is between 5 and 95. So final minus initial would give me 90 as my temperature change. So for this one, I would end up with 4,514 joules, which I could leave it like that because it doesn't ask for it in kilojoules, but I'm going to go ahead and convert it. So this ends up being 4.51 kilojoules. So this is another one where you only need one step. But on this one, you only need the Q equals MC delta T step instead of just the conversion step. So again, the most important thing here is to start by figuring out where you are, where you're going, so that you know how many steps you need to do. Now, when you get to the last one, I'm not going to work the last one out for you, but for the last one, it's very similar to the first problem we did, but it's going backwards. So technically it's a cooling curve instead of a heating curve. So the major difference there is going to be that all of your values are going to be negative because it's actually exothermic instead of an endothermic process like a heating curve would be. So same process, the only difference is you're going to make sure that everything is negative when you add them up, so you should have a negative number when you get finished.